You know what makes something alive, right? It eats, it grows, it responds to its environment, it processes information. Simple enough, except here's what nobody really sits with. The universe does all of these things, not metaphorically, not poetically. When you actually look at the mechanics, the energy flows, the self-organization, the information processing happening at cosmic scales, the line between living system and universe gets uncomfortably blurry. We've spent centuries defining life as this special category, this thing that happens only in the thin biological layer of certain planets. But what if we've been looking at it backwards? What if life isn't a rare exception to cosmic rules, but rather a small-scale expression of what the universe has been doing all along? Let's start with something concrete: metabolism. Every living thing, from bacteria to blue whales, maintains itself by cycling energy and matter. Take in fuel, transform it, export waste, repeat. It's the fundamental signature of life. Well, the universe does this too, and it's been doing it for 13.8 billion years. Stars are cosmic metabolic engines. They consume hydrogen, fuse it into heavier elements through nuclear fusion, radiate energy, and eventually die in processes that seed space with the building blocks for new stars. The entire cycle, nebula to star to supernova to nebula, is a metabolic loop operating at scales we can barely fathom. Our galaxy alone converts about 3 solar masses of material into new stars every year. That's roughly 6 trillion kilograms of matter being processed annually just in the Milky Way. Multiply that by 2 trillion galaxies, and you're looking at a universe that metabolizes matter and energy more efficiently than any organism we've ever studied. But metabolism alone doesn't make something alive. Living systems also grow and evolve. They increase in complexity over time. They develop structure. And here's where it gets interesting. The universe has been doing exactly this since the moment of the Big Bang. In the beginning, everything was essentially uniform, a hot, dense soup of fundamental particles with almost no structure at all. Fast forward 13.8 billion years, and you have galaxies, stars, planets, molecules, cells, brains, civilizations. The universe has been on a one-way journey toward increasing complexity and organization for its entire existence. Astrophysicists have calculated that the universe today contains approximately 10 to the power of 90 bits of information. That's the total information encoded in the positions, velocities, and quantum states of every particle. In the early universe, that number was effectively 0. Information has been created, accumulated, and organized over cosmic time. The universe hasn't just grown in size through expansion, it's grown in complexity, in structure, in the richness of what it contains. Consider self-organization. Living things don't need external instructions to form complex structures. They do it spontaneously through the interplay of simple rules and energy flows. Your body right now is maintaining trillions of molecular interactions without conscious oversight. The universe does this at every scale. Gravity acts on slight density variations in the early cosmos, and those tiny irregularities, fluctuations of just 1 part in 100,000, amplify over time into the cosmic web, vast filaments of galaxies separated by enormous voids, all organized without any blueprint or external coordinator. Dark matter, which makes up about 27% of the universe's mass energy, forms invisible scaffolding that guides visible matter into coherent structures. Galaxy clusters emerge, stars form, planetary systems coalesce. All of this happens through self-organization, local interactions following physical laws, producing global patterns of extraordinary complexity. And this is where it gets truly strange. The universe processes information, not in some vague philosophical sense, but in ways that physicists can actually measure and study. Every physical interaction, every particle collision, every electromagnetic exchange, every gravitational influence is fundamentally an exchange of information. The laws of thermodynamics tell us that the universe is constantly transforming energy from organized to disorganized states, from low entropy to high entropy. But within that overall trend toward disorder, pockets of decreasing entropy emerge. Stars, planets, living cells. These are regions where information becomes concentrated, where order increases locally even as the universe as a whole trends toward chaos. Your brain, right now, is one such pocket. A temporary reversal of entropy, a concentration of information processing made possible by the energy flowing through you from the sun. But here's the thing. You're not separate from the universe doing this. You're an example of the universe doing what it does, creating islands of complexity in a sea of increasing disorder. If questions like these are what keep you up at night, consider subscribing. We explore the biggest scales and smallest mysteries every week, always looking for the places where our intuitions about reality turn out to be incomplete. Let's think about responsiveness, the ability to react to environmental changes. Living organisms sense their surroundings and adjust their behavior accordingly. They maintain homeostasis, that delicate balance of internal conditions despite external flux. The universe does something remarkably similar through feedback mechanisms operating at cosmic scales. Star formation rates, for instance, are self-regulating. When a region of space forms too many massive stars too quickly, their stellar winds and supernova explosions heat the surrounding gas, suppressing further star formation. When star formation slows, the gas cools and condenses, triggering new stellar birth. The universe maintains a kind of cosmic homeostasis, balancing destruction and creation across billions of years. Dark energy, the mysterious force causing cosmic expansion to accelerate, might be the universe's response to its own gravitational dynamics, a kind of cosmic scale feedback mechanism we're only beginning to understand. Around 68% of the universe's total mass energy is dark energy, and we don't know what it is. But we can measure how it responds to the universe's expansion history, how it changes the geometry of space-time itself. Now you might be thinking, okay, but living things reproduce. They make copies of themselves. The universe is just one thing. It doesn't reproduce. Well, maybe not. There's a speculative but mathematically consistent idea in cosmology called eternal inflation. The theory suggests that our observable universe, those 93 billion light years we can see, might be just one bubble in an eternally inflating multiverse. Quantum fluctuations in the inflating field could spawn new bubble universes constantly, each with potentially different physical constants, different laws, different possibilities. If this model is correct, the universe might reproduce in a way that makes biological reproduction look simple by comparison. Each bubble universe would be causally isolated from the others, completely unreachable, existing in its own pocket of space-time. And yes, that is speculative. We have no way to test it currently. But the mathematics of inflation naturally leads there, which is worth sitting with. Here's what really challenges our definitions. Consciousness. We tend to think of awareness as the ultimate dividing line between living and non-living. But consciousness might just be what information processing feels like from the inside when it reaches a certain threshold of complexity. Your neurons aren't individually conscious. They're just cells following chemical and electrical rules. But 100 billion of them, interconnected in specific patterns, produce the felt experience of being you. The universe contains approximately 10 to the power of 24 stars, 100 billion trillion. Each star is a nuclear furnace processing information through fusion reactions. Each galaxy is a gravitationally bound system of hundreds of billions of stars, all influencing each other, all exchanging information through gravitational fields and electromagnetic radiation. We don't know if there's any threshold of complexity or connectivity where information processing becomes experience. We don't know if the universe has anything like an interior perspective on its own processes. But we also can't rule it out based on what we currently understand about how consciousness emerges from physical systems. Drop a comment and tell me what aspect of this question unsettles you most. The possibility that we're part of a living cosmos, or the possibility that life might be too small a category to capture what's really happening. What does it mean for something to be alive if the universe itself exhibits every functional characteristic we use to define life? Maybe it means our definition has always been too narrow, too centered on the particular chemistry and timescales of Earth-based biology. We define life as carbon-based because that's what we know, operating on timescales of seconds to centuries because that's what we can observe. But if you're a mayfly living for a single day, a redwood tree that lives 3,000 years might as well be eternal. Its growth imperceptible, its metabolism impossibly slow. To the mayfly, the tree might not seem alive at all. Now imagine you're a human, living decades to maybe a century, trying to understand a universe that operates on timescales of billions of years. A galaxy collision unfolds over hundreds of millions of years. Star formation cycles span tens of millions. Even the fastest cosmic processes, supernova explosions, gamma-ray bursts, are instantaneous only by comparison to the deep time of cosmic evolution. We might be mayflies trying to recognize the forest. The universe exhibits energy metabolism through stellar fusion and cosmic cycles. It shows growth and increasing complexity from the Big Bang to the present. It self-organizes into hierarchical structures without external guidance. It processes information at every scale, from quantum interactions to galactic dynamics. It responds to its own state through feedback mechanisms we're still mapping, and it might even reproduce through eternal inflation, spawning causally isolated offspring universes. Every functional criterion we've developed to identify life, the universe meets it, not through magic or mysticism, but through the same physics and chemistry that govern living cells. The only difference is scale and speed. Which brings us back to where we started, that uncomfortable blurring of categories. Maybe life isn't a binary state, alive or not alive. Maybe it's a spectrum of self-organizing, information processing, energy metabolizing complexity. On one end, you have simple physical systems, rocks, clouds, rivers. They process energy and information, but barely with minimal structure or responsiveness. Move along the spectrum and you find chemical reactions, then autocatalytic cycles, then primitive cells, then complex organisms, then ecosystems, then civilizations. And maybe at the far end of that spectrum, you find the universe itself, the largest, longest-lived, most complex self-organizing system we know of. We're not separate observers looking at a dead cosmos. We're temporary concentrations of the universe's own tendency toward complexity and organization, brief moments when the cosmos looks at itself and asks questions. There's something deeply strange about being a collection of atoms arranged in such a way that those atoms can contemplate the arrangement of all atoms. You are the universe experiencing itself, processing information about its own structure, asking whether it might be alive. That's not poetry, it's an accurate description of what's physically happening right now. The calcium in your bones was forged in stellar explosions. The oxygen you're breathing was created by stars that died billions of years ago. Every atom in your body is a piece of cosmic history, temporarily organized into a pattern that thinks and feels and wonders. When you look at the night sky and feel small, you're feeling the truth. But you're also missing something. You're not separate from that immensity. You're continuous with it, made of it, expressing it. We might never know if the universe has anything like awareness or purpose or intention. Those might be the wrong questions entirely, categories too small for what's actually happening. But we can know this: the cosmos has been creating complexity, processing information, and organizing itself for nearly 14 billion years. And at least in one small corner on one unremarkable planet, that process has produced beings capable of understanding it. We live at a moment in cosmic history when the universe has become capable of asking whether it's alive. Whatever the answer turns out to be, the question itself is extraordinary. And that's worth some quiet gratitude. We get to be here, aware, wondering about the deepest nature of existence, even if just for a moment. Even if we're mayflies contemplating redwoods, even if the question itself is part of the universe trying to know what it is,